So hello, good morning dear students. We're here again in our math channel for you to learn another math lesson for today. So our topic for today is all about the remainder theorem and the synthetic division of polynomials. Now regarding the remainder theorem, this is what you need to know about remainder theorem. The remainder theorem states that if a polynomial f of x is divided by x minus k, then the remainder r is equal to f of k. It can assist in factoring more complex polynomial expression. The factor theorem states that polynomial f of x has a factor x minus k if and only if f of k is equal to 0. Now you will understand this theorem about the remainder theorem later on when I give you some examples. Let us have an example. F of x is equal to 2x cubed minus 5x squared plus 6x minus 12. Now we will find out if x minus 4 is a factor of this given polynomial. Now x minus 4 is also equivalent to x equal to 4. So f of x is equal to f of 4. So what we need to do for us to know if there is a remainder when we divided a polynomial with a given polynomial, we will substitute the value of 4 from the given polynomial. So from the given function, we have 2 times 4 cubed minus 5 times 4 squared plus 6 times 4 minus 12. Now 2 times 4 cubed is equal to 2 times 64 minus 5 times 4 squared is equal to 16. That is 5 times 16 plus 24 minus 12. So 2 times 64, that is 128 minus 5 times 16, that is 80 plus 12. So that is equal to 48 plus 12, and that is equal to 60. Meaning f of 4 is equal to 60. Meaning this is not a factor of the given binomial, and it has a remainder of 60. That is the use of the remainder theorem. Now we will try the synthetic division to find out if we will get the same result. So we have f of x is equal to 2x cubed minus 5x squared plus 6x minus 12. So the first thing that we have to do is to get the numerical coefficient of the given function. So we have 2, we have negative 5, we have 6, we have negative 12. And we will place here 4. So what we need to do is to bring down 2. 2 times 4, that is equal to 8. Then negative 5 plus 8 is equal to positive 3. 3 times 4, that is equal to 12. 6 plus 12, that is 18. 18 times 4, that is 72. Negative 12 plus 72 is equal to 60. So therefore, we arrive at the same result, wherein the remainder is 60. So f of 4 equal to 60, meaning remainder of the function f of c, and 60 is the remainder of f of 4. Let us have another example. We have f of x is equal to 3x raised to 4 minus 7 x cubed minus 9x plus 12. And we have f of 5. So we will be using synthetic division. So we have 5, we have 3, the numerical coefficient of x raised to 4, negative 7, we have no value of x squared, so we will replace it by 0. We have negative 9 and positive 12. So again, we will bring down 3, then multiply it with 5. 3 times 5 is 15, negative 7 plus 15 is equal to 8. 8 times 5 is equal to 40. 0 plus 40 is 40. 40 times 5 is 200. Negative 9 plus 200 is 191. 191 times 5 is 955. 12 plus 955 is 967. So our answer is 967. Now we will find out if we will get the same result if we will use remainder theorem. So f of 5 is equal to 3 times 5 raised to 4 minus 7 times 5 raised to 3 minus 9 times 5 plus 12. Again, what we did is just we substituted the value of 5 to the x values. So that is equal to 3. 5 raised to 4 is 625 minus 5 raised to 3 is 125, so 7 times 125 minus 45 because that is 9 times 5 is 45 plus 12. So that is equal to 3 times 625. So that is equal to 1875 minus 875, which is the product of 7 times 125 minus 45 plus 12. So we will solve it now. 1875 minus 875 is 1000. 1000 minus 45 plus 12, so that is equal to 967. So we arrive at the same answer. Let us have another example. We have f of x is equal to 2x raised to 4 minus 3x squared plus 30. First is we will be using the synthetic division. So again, we will put here 3 and then the numerical coefficient of the polynomial. So 2, we don't have x raised to 3 value, so we will replace it by 0, minus 3. Then again, we don't have x value, so we have 0 plus 30. So we will bring down 2. 2 times 3, that is 6. 0 plus 6, that is 6. 6 times 3, that is 18. Negative 3 plus 18 is 15. 15 times 3 is 45. 45 times 3 is 135. 30 plus 135 is 165. So we found out using the synthetic division that the remainder of this given function is 165. Now we will be using the remainder theorem to find out if we will arrive at the same answer. So we have f of 3 is equal to 2 times 3, changing the value of x by the function 3. 2 times 3 raised to 4 minus 3 times 3 raised to 2 plus 30. So we have 3 raised to 4, that is 81. So 2 times 81 minus 3 times 9 plus 30. We have 162 minus 27 plus 30, that is equal to 162 plus 3. So that is equal to 165. So as you can see, students, we arrive at the same answer using the synthetic division and the remainder theorem. So this is our topic about remainder theorem and synthetic divisions of polynomial. I hope you learned something from our discussion for today. If you want more videos like this, just click the subscribe button and the notification bell below this video so that you will be updated with our future uploads in this channel. So that's all for now. Have a nice day, everyone.